Okay, continuing on with the Algebra 1 third 9 weeks practice. Look at part A here. Solve the system by graphing and approximate answers. So if I take the first equation, y equals 1/2 x, b in this case is 0 because there's no number being added or subtracted to it. So my first dot's going to be at 0. My slope is 1/2, so it's rise over run, so I go up 1 over 2, and I would draw my line. My second equation, b is 2, so I start at 2, and then m is 1 because there's an imaginary 1 there, so m is 1 over 1, so from that 2 I go up 1 over 1. And then what we're trying to figure out here is where they cross. So mine appear to cross here, which is at -1, 2, 3, 4, 5, -3. So about -5, -3. Now yours may be a little different depending on how accurate your lines were. Okay, objective 12 was graphing linear inequalities. So they're in slope-intercept form because the y is by itself. So b in this case is -4, so I go down 4 on the y-axis. M is 3 or 3 over 1, so from there I'm going to go up 3 because it's positive and then over 1. Remember, with inequalities you have to check whether it's a solid or dotted line. So since there's no line under the inequality sign, it's a dotted line. Then you have to look at shading. So this is a greater than sign, so you shade above the line that you drew. So above the line that you drew would be all this area. Okay, 13 is dealing with compound inequalities. So let's look at part C on 13. It says Paul has to sell at least 5 magazines, but no more than 30 to go on the senior trip. Represent this situation on a number line and with the compound inequality. I'm not really too concerned about the number line right now. So, has to sell at least 5, but no more than 30. So if he has to sell at least 5, we'd have less than or equal to. No more than 30 means he could still sell 30, so that's also less than or equal to. If you're setting up a compound inequality like this, these are always going to be less thans. It's just a matter of can it equal to 5 and can it equal to 30. So then we have to add the equal to in this case. Okay, 14 was on kind of fundamental counting principle. So let's look at part B. How many possible variations of regular Coke are there if you put 3 flavor add-ins and have 12 flavors to choose from? No repeats allowed. So I've got 3 flavor add-ins I'm going to put in, and I've got 12 to choose from, but no repeats. So I could put 12 choices for that first add-in, but since I can't repeat it, then there'll only be 11 choices for the second and 10 for the third. So 12 times 11 times 10 is 1,320 different possibilities I can make, or different variations of Coke with 3 different add-ins. Okay, 15 dealt with distance versus time graphs. So it says Mark ran from his home to the park. He rested on a bench for a while before running back home at a faster speed than he went to the park. Sketch a graph to represent Mark's distance from his home over time. Identify the independent and dependent variable. So the independent variable is going to be time, and the dependent variable is going to be distance. So we're sketching a graph where I've got time on the x, because that's the independent variable, distance on the y. So it says Mark ran from his home to the park, so he started at his home, went from his home to the park. He rested on a bench, so he didn't travel any, he's just staying flat. The graph's staying flat, so he's not moving. Then it says he went back home at a faster speed. So since it says faster, this last part here has to be steeper than the first part, because the steepness on a distance versus time graph tells you if they're going faster or slower. So it has to be steeper than that first part. Okay, 16 dealt with solving quadratics by factoring. So I'm going to do part B in this case. So if we're solving this by factoring, we're still going to make the diamond. And if I make the diamond here, A is 1 times C is negative 72, so I have negative 72 on top. And I have negative 1 on the bottom. So that'd be negative 9 and positive 8. So this would allow me to write x minus 9 times x plus 8 equals 0. Since I'm solving it, I'm trying to figure out, okay, what values of x makes each parenthesis 0. So in other words, what minus 9 gives you 0? Well, that's positive 9. What plus 8 gives you 0? Well, that's negative 8. So I have two answers of 9 and negative 8 that would make that solution. Okay, if I look at number 17, negative exponents. So the first thing I want to do is rearrange it so I don't have negative exponents. So here I've got a 3x that's going to stay on top. Since it's y to the negative 2, we move it from the top to the bottom and make the exponent positive. The 9 is going to stay on the bottom. Since it's x to the negative 6, I'm going to move that to the top and make it x to the 6th. And then I have a y to the 3rd that's staying on the bottom. So if I reduce this now, 3 over 9 reduces to 1 over 3, so you can put that 1 up there if you want, you don't have to. Since these are both on top, we're going to multiply them together, but we're going to add the exponents, so it'd be x to the 7th. Same thing here, we're going to add the exponents, so it'd be y to the 5th. Okay, number 18 was solving quadratics with the square root method. So that means we want to get this x squared by itself. So I'll do D on this one. So I want to get the x squared by itself, so I'd have to add 6 in this case, which would give me 3x squared equals 147. Then divide both sides by 3, and I get x squared equals 49. And then to undo the squared, we take the square root of both sides. Square root of x squared is x, and then remember it's plus or minus, in this case 7, because the square root of 49 is 7. Don't forget your plus or minus sign. Okay, exponential graphs. And this is where I talked about, I just want you to kind of make a table here, and then we'll estimate and sketch our graph the best if we can. So if I take this one, y equals 3 to the x minus 7. So let's just make a table. We'll just go 5 points here. So if I substitute negative 2, that means I'd have 3 to the caret key negative 2, and then minus 7. So that's negative 6.8, roughly. If I put in the negative 1, 3 to the negative 1 minus 7 is negative 6.6. If I put in 0, 3 to the 0 minus 7 is negative 6. If I put in 1, 3 to the first minus 7 is negative 4. And if I put in 2, 3 to the second minus 7 is 2. So if we tried to graph these points, negative 2, negative 6.8 would be down here somewhere. Negative 1, negative 6.6. 0, negative 6. 1, negative 4. And then 2, 2. So our graph something like that. Okay, number 20 was finding the vertex of a parabola or quadratic equation. So the vertex, I can get this to focus again. Okay, so if I take part C here, y equals negative x squared plus 6x plus 4. Your vertex is the point negative b over 2a, and then f of negative b over 2a. Now all that means is we find negative b over 2a, and then we plug it in. So remember, a is still the number in front of x squared, b is the number in front of x, and c is the constant. So here, negative b, which is 6, over 2, a, since there's a minus sign, a is negative 1. So a negative 6 over 2 times negative 1 is negative 2. And if you divide that, you get 3. So what that means is the x-coordinate of our vertex is 3. The y-coordinate we're going to get by plugging in 3 for the x's. So it'd be y equals negative 3 in parentheses squared plus 6 times 3 plus 4. And again, when you enter that in a calculator, enter it exactly how it is. So negative parentheses 3 parentheses to the second plus 6 parentheses 3 plus 4. So you get 13. So that means the vertex would be 3, 13.